Hello and welcome, I'm your Code Monkey, and here let's build a really nice feature-complete camera system. We want the ability to move, rotate, zoom in and out, enable edge scrolling, and touch drag to pan the camera. This is a great and very capable system for just about any game where you want the player to have direct control over the camera. You can follow this tutorial and download the final project files. We're going to build it in a 3D scene, but in the end I will also quickly show a conversion to make it work in 2D. Now, this video ended up pretty long, but it's the only video you need to make a fully complete camera system, so if this is something that you need, make sure you watch the full video to the end. If you prefer a more guided path with step-by-step lectures, then check out my complete courses. Learn how to make a Builder Defender game using C#, or learn how to make games entirely using visual scripting. Perhaps if you're past the beginner stage and want to make the jump to advanced, then check out my turn-based strategy course to learn how to manage a more complex project and write some good clean code. Or learn all about Unity with the Ultimate Unity Overview course, which contains over 50 lectures, each covering a different tool or feature of the engine. I'm always available in the Q&A section, answering your questions every single day. So check them all out with a link in the description. Alright, so let's build our camera system. Now of course, to do it, we are going to be using Cinemachine. If you have never used it, I covered it in detail in another video. Basically, Cinemachine is an excellent Unity built-in tool that makes everything related to cameras so much easier. We're going to see how we can build a basic camera in just a few seconds as opposed to minutes or hours if we built it all ourselves. And for the demo scene that I'm using here, this one is from the recently released Cinti Ancient Empires pack. It's a gorgeous pack with a really awesome Roman or Greek theme. There's a link in the description if you want to get it for yourself. Alright, so let's do it. First of all, let's create a brand new virtual camera. So let's go up into Game Object, then down here find Cinemachine, and then let's create a standard virtual camera. Let's rename this to Cinemachine Virtual Camera, and that's it. Okay, so with this here, we already have a nice virtual camera. And the way that this system is going to work is we are not going to directly move this object. So the virtual camera, we're not going to directly move this. Instead, we're going to move another object and then set this virtual camera to follow and look at that object. So let's do that. Let's right click on the hierarchy and let's create an empty game object. Call it the camera system. Let's reset transform to 0, 0. Let's go into the virtual camera and just drag the reference as the follow. So if we see on the camera, it is currently positioned exactly on top of that object, which is on 0, 0. Then let's also add the same object reference as the look at. And now with this, actually the camera is already working. To test that out, let's hit on play. So here the game is running and the camera is already working. Let's just play around with the fields here. The goal is for this object, the camera system, so the target object, for that one to be right on the floor and the camera is above it and looking down. So for that, on the virtual camera, let's expand the body, and over here we've got the follow offset. By default it's at 0, 0, minus 10, so we can actually look in the scene view to see what the default looks like. So yep, there's the object right there, the target object, and the virtual camera is 10 units in the Z behind it. Like I said, we want an overhead camera. So on the virtual camera, let's increase the follow offset by quite a bit. Let's lift it up on the Y. So put it something like this. Then on the Z, also push it quite a bit more back. So a bit lower, a bit higher, something like this. Okay, so just with these basic settings, you can already see it working. Here with the game view and scene view side by side, we can already see the object. And if I manually move it, yep, there you go. You can see the camera perfectly follows. So this is how we're going to do. We're going to move this object and the camera will automatically look at it. So let's make a script to do that. But before we exit play mode, let's make sure to go into the virtual camera. And over here, make sure we tick save during play, so we don't lose all the changes that we did so far. And also let's push this a bit back, so a bit more of a front view. Okay, like this. Alright, so those are the settings that I want. Make sure save during play is ticked. Now if we exit play mode, yep, there you go, all of the changes were saved. Let's just move the camera system game object, move it by default, something like this. Also rotate it, we're going to see rotation in a bit, but just right now it already works. Alright. Okay, so with this, like I said, let's make that script. So let's right click on the project files, create a new C# script, call it the camera system. Let's select the camera system game object and attach the script. Alright, so here let's just do some basic input logic. So let's do it by going into private void update. Now here let's just add some basic input logic. Alright, so here it is, so just testing for WASD. Now naturally, you could easily replace this with new input system, which I covered in detail in another video. So with this, we have a move direction. Also note how, since we're working on a 3D game, look at how I define a vector 3, and when pressing the W or the S key, I'm modifying the Z, not the Y. That's because we're in 3D, so when moving forward, we want to go forward, not up. So we have this move direction. However, here, you need to be careful with how you actually move this object. You might think that you could just add this move vector straight onto the transform position. So just go transform.position plus equals the move direction multiplied by a certain move speed and by time.time to make it frame rate independent. So here you could define the move speed and put it at some value. So you might think to do this, but if we do, let's see what happens. So here I am, and if I press on W, yep, it does move forward. Press on S does go back, press on D go right, press on A goes left. Okay, so it does seem like it actually works. However, if I unmaximize this window, now with the scene view side by side, let's select the camera system game object, and over here let's apply a rotation. So let's put it maybe 90 degrees. So the camera is now rotated. And right now if I do the same thing, so let's see what happens when I press on W, and there you go, it moves to the left. And now if I press on D, yep, now it moves forward, now S, A, and so on. So this is the issue with this code. When I press W, I want it to move forward, but when I do, now it's moving to the left. That is because it's moving into the global forward, which in this case, with the camera rotation, the global forward is still pointing in this direction, so when I press on W, it still goes there. Now obviously this is not correct, this is not what we want. We want to take the rotation of this object into account in order to decide how we should move. So back in the code here, how we solve this is actually pretty simple. Instead of moving directly by the moved ear, what we want to do is to use the super useful transform vectors. So let's calculate the final moved ear, so let's actually rename this one. So for this one, instead of moved ear, let's rename it. So the Visual Studio shortcut is Ctrl-RR. Let's rename this to the input ear. Then we calculate the final moved ear. And for this one, like I said, we're going to use the super useful transform vectors. We're going to use transform.forward. So this is the forward vector for this transform. So this takes rotation into account. So we multiply this one by the input ear.z. And then we add the transform.right. Again, this one is also affected by the rotation of this game object. We take this one and we multiply it by the input ear.x. So with that, now we have the correct move direction based on the object's rotation. So we now use this in our movement. And if we test it like this, here it is with the camera rotated on 0. So if I press W, S, A, and D, yep, it still works perfect. Now if I rotate the camera, so again, let's apply a 90-degree rotation. Now I press on W, and yep, there you go, it does move forward, S, D, and A. All right, awesome. All right, so here everything is working correctly. We can move in any way we want. Now at this point, we should probably tweak some settings. Here, notice how the camera is indeed moving as we want, so move up, down, right, left, and so on. But since we're also looking at the invisible target in front of here, due to the smoothing that we have, it creates a bit of an odd result. So as I press on W, you can see the camera kind of shifts a bit upwards. And if I go to the right, it kind of has a slight delay. Now, perhaps this is what you want. If so, then don't bother with the tweaks that I'm going to mention. But in most cases, you want the camera to pan right away instead of going slightly behind the target. Thankfully, like I said, since we're using Cinemachine, this is super easy to do. So let's just select the Cinemachine virtual camera. Let's expand over here the body, and then we've got the X, Y, and Z damping. If we set all of these back down to 0, yep, there you go, now the camera does move much more snappy. Again, like I said, this is personal preference, and it kind of depends on what type of game you're trying to make, but generally I prefer like this. I prefer my camera to be much snappier. Okay, so with this, the movement is working. Next up, let's enable rotation. For this one, it's also going to be super simple. We already saw how we're going to do this. Since we defined the camera over here with the follow offset with a negative on the Z, that means the camera is always behind the target object. So there's the camera and the target object is down there. Since the camera is already behind, all we need to do is rotate this object. So over here on the Y rotation, all we need to do is play around this and we can easily rotate the camera. So here in the code, it's super simple. Again, let's do some input. So again, just using some basic input on Q and E in order to rotate. So we get the rotate direction. Then in order to rotate the object, we can just modify this transform.Euler angles. And let's add it based on U vector 3. For our 3D camera, we only want to rotate around the Y axis. You can verify what rotation you want if you look over here in scene view. So if I rotate around the Y, yep, you can notice that it rotates exactly as we want. Whereas on the X, it does this kind of rotation. That's not what we want. And the Z does this kind of rotation, also not what we want. So what we want is rotate on the Y. So over here, create new vector 3, 0 on the X, 0 on the Z, and let's just put over here on the Y. And for the Y, let's use rotate direction multiplied by a certain rotate speed. And finally, just multiply by time.delta time. Alright, so that's it, some extremely simple logic. Let's test. Alright, so here we are. Now if I press on E, yep, there you go, rotates, press on Q, and yep, it does rotate. Alright, so yep, it does work. Now it's going a bit way too fast, so let's actually reduce that. And also if you want the opposite, so if you want to press E and rotate in the other direction, then over here just swap these, make this one minus and this one plus. But in our case, it's working exactly as I want it. Let's just lower the rotate speed a bit slower. So here, press on E, and yep, does rotate, press on Q, and does rotate. Okay, great, but we do see the same issue that we saw previously. So as I rotate, the camera is slightly lagging behind, so that does not look very good. So once again, the solution is the same. Let's go into the virtual camera. Now let's expand the aim part. And over here, we've got the horizontal and vertical damping. Let's just put both these at 0. And now the camera, yep, perfectly nice and snappy. So by moving, rotating, all of it works perfectly. Okay, great. Now remember, make sure you toggle save during play before you exit play mode. And here it is, the camera working really nice, really perfect. So we can now move anywhere, we can rotate anywhere, and everything works great. Alright, so that's it. Next up, let's handle edge scrolling. This one is also pretty simple. Over here in our movement code, we are testing for player input, but we can also create an input direction based on the mouse position. For that, we have the input.mousePosition. This gives us the mouse coordinates in pixel units. So if we do a quick debug.log and test this, yep, there it is. Here in the log I can see, and if we look in the stats, we can see the size of this window. So you can see that I've got this window set up as 1080p, so that's because over here I've got Full HD selected. And to check out what input.mousePosition returns, we can see that if I put the mouse over here on the lower left corner, yep, it returns pretty much 0, 0. And if I put over there on the top right corner, it returns 1920 by 1080. So input.mousePosition gives me the screen pixel coordinates. With this, we can just do some basic math. All we need is to get the total width of the screen, get the total height, then check if the mouse is within a certain distance from the left side. So for example, if it's under 10 pixels of the left side, then we move to the left. If it's within 10 pixels of the right, then we move to the right, and so on. Okay, so here in the code, let's do that. Let's first define just an edge scroll size. So an int edge scroll size, maybe 20 units, maybe 20 pixels, maybe that's enough. Then we just do some simple logic. So if the input.mousePosition.x, if this one is under this amount, under the edge scroll size, then that means the mouse is on the left side. If so, then let's set the input here.x to -1f. Then we test for the mousePosition.y. If it's under that one, then we want to move down. So that's the z -1. Next up, we want to test if it's on the right side. So for that, we're going to test the mousePosition.x. And we're going to test if it's past the screen.width. This is how we get the screen width. So that one, we subtract the edge scroll size. So if the mouse is to the right of this point, then we want to move on the x by +0.1. And finally, the opposite. So this one is on the y. Let's use the screen.height. And this one, we move on the z on +1. Alright, so that's it. Really super simple. Let's test. So here we are with the mouse in the middle of the screen. Now if I approach the mouse on the left side, yep, there you go, pans left, pans right, pans forward, and backwards. Alright, awesome. Everything works. Now when it comes to edge scrolling, some people like it and some people don't. So usually you want to add it as an option rather than making it always enabled. So for that, we can just go up here, make a private bool, use edge scrolling. You can default it to either true or false. And if you want, you can even make this a serialized field in order to make the default shown in the editor. And then over here, we just use this logic if this one is true. So if use edge scrolling, then we do all of this. And if not, then we don't do any of this. All right, so that's it. Some super simple logic. And obviously you would control this boolean based on the player's options. All right, now for the final movement method, let's add a click and drag. So I want to be able to, for example, place the mouse here, use the right mouse button, keep it held down. Then I move the mouse in this direction and the camera moves in that direction. So that's what we want to do. Okay, so here in the code, so let's begin by testing out our input. Like I said, I want to use the right mouse button. So input.getMouseButton. Test for the get mouse button down. So we want to know when we press it. So on the right mouse button, so that's on 1. Again, of course, you could swap this out for touch or any other input. I'm just using the mouse just because it's nice and simple. So when we do press the mouse, let's set a certain boolean to true. So let's go up here and let's define a private bool, call it drag pan move active. Okay, and then down here, when we press the mouse button, let's set this to true. And let's set another one. For this one, let's use get mouse button up. So when we release, then we set this back into false. Okay, so we have this nice boolean knowing when we should pan or not. Now with this, we're only going to run the drag pan logic while this one is true. So after this, we do if this logic is true, then we're going to apply the drag pan move. Okay, so in order to pan, we need to know the last mouse position so we know how much it moved in the last frame. So for that, let's store it. Let's define a private vector2, since the mouse only has a vector2, for the last mouse position. And then with this one, let's go down here. As soon as we press, let's set it. So this one equals input.mousePosition. And then down here, while it's active, so while we still have the last mouse position with the last mouse position, with this one, we can calculate a vector2 for the mouse movement delta. So this is how much the mouse moved in the last frame. So we just take the input.mousePosition. So actually up here is the mouse position, not the mouse scroll delta. So we take this one and we subtract the last mouse position. And here, for some reason, the mouse position actually is a vector3, not a vector2. So we can easily just cast this down into a vector2 before doing the math. All right. So with this, we have the mouse movement delta. So we handle all of that. And then in the end, after all the logic, then we update it with a new value. Now we can do a debug.log to see what this shows, so we understand how this logic is working. So here's the log. Now if I right click and if I hold still, it's 0, 0. Now if I move the mouse right and up, so move it, yep, there you go, we've got plus and plus over there. And if I right click and I go down and left, there you go, we've got negative values. So this is the amount of pixels that the mouse moved since the last update. So with this, we can now use this delta in order to directly move the transform. For that, let's actually put all of this logic above before we move the transform. We're going to refactor all this code in a bit. So we've got this. Now let's just convert the mouse movement delta into the same as the input direction. So here we set the input dir.x equals the mouse movement delta.x, but then we modify the input dir.z based on the mouse movement delta.y. Because over here we're working with a vector2, but with the input we're using the z. Okay, so that's it, except with this it's going to move way too slow. So let's define a float for the drag pan speed. Then we just multiply it by the drag pan speed. Okay, so let's test. So here we are, the camera is static. Now if I right click and I move the mouse, and if there you go, it is panning there, there, and there. All right, awesome. So with this, we are directly using the mouse in order to pan the camera anywhere we want. We've got that field if we feel that this is way too sensitive, but yep, the logic is working perfectly. All right, awesome. So we already have quite a lot of things working. Now, before we move on to the zoom, let's actually refactor our code. Like I said, I want this video to serve as the ultimate camera controller. So let's refactor all of this to make the code really nice and easy to read, and also really easy to define which features you want to use. Like perhaps you don't want the drag pan, or perhaps you don't want edge scrolling, so let's do that. So first of all, let's make two functions, one to handle the movement and one to handle the rotation. So for the rotation, that's just this code. So just copy this and we call this on the update. All right. And for the movement, let's first of all copy all of this. So all of this in there, and on update, we call handle camera movement. Okay, so right now everything is still working exactly the same as previously. But like I said, we want to refactor this in order to be able to use or not use edge scrolling. Same thing for the drag pan. So let's actually make separate functions for each of these movement types. So let's go down here, make another function. Private void, handle camera movement, edge scrolling. And let's make another one. So another private void, handle camera movement. For this one, call it drag pan. Then all we do is just copy all this logic. So the use edge scrolling, let's copy onto this one. And then for the other one, the drag pan, let's copy all of this one. And of course, we need to use the input here since we're reusing it. So let's define another input here. And also same thing for this one. Okay, so with that works, now in these two functions, we just need to apply the final movement. So that's this logic right here. So just copy it, apply it to the end here, and apply it to the end here. All right, so everything's working, no more errors. Now we can just add all of the functions depending on all of the features that we want for this. And now we can easily either enable or disable these based on a boolean. So we've got the use edge scrolling. Now for another one, use drag pan. Then let's put the ifs on this one. So test for the if in here instead of testing inside this function. So over here, let's get rid of this one. So that one always runs. And then same thing, another if on this one. All right, so that's it. Now it's super simple. All we need to do is modify either of these variables and the logic will work exactly as you want it. Here is the camera system with all the features enabled. So I've got edge scrolling if I go to the sides. Yep, I've got the regular movement, I've got the regular rotation, and the regular pan movement. All right, awesome. Okay, so with that, the code is working, all of the logic works. Now the last thing that we need to handle is the zoom. And for that, there's actually two ways to zoom a camera. One way is to bring the camera in closer. So on the virtual camera, one way to zoom is to get it closer on the Z and also closer on the Y. So this applies certain zoom. And another alternative is to simply change the FOV. So as we lower the FOV, yep, it looks like a zoom. So both these approaches work as kind of a zoom. They're different, so it depends on which one you want. Let's see how both those work. Okay, so over here, let's keep writing some good clean code and call handle camera zoom. So let's make this function. So down here, make a prod void, handle the camera zoom. All right. Now here, the first thing that we need is some input. And for zooming, what makes most sense is the mouse scroll wheel. So let's handle that. We can easily access that with the input.mouse scroll delta. Now this one, as you can see, it's a vector 2 because apparently there are some mice that scroll on the X. But chances are for a zoom, you want to scroll on the Y. So we've got this one .Y. If we just do a debug.log on this to see what it does. Here, if I scroll forward, yep, we do see the value change. We do see a +1. And if I scroll the wheel backwards, so back to me, we do see some negative values. Okay, so these are the values that we can use to run our zoom logic. So over here, let's try handling the field of view method first. Now, this is actually the more complex part due to how Cinemachine actually works. You might think that you can just access the virtual camera and search for a field of view field. So first we need a reference to the virtual camera. So let's make one. Let's make it a serialized field so we can set it in the editor. For the Cinemachine virtual camera. And for this, we need to add using Cinemachine. So we add this for the Cinemachine virtual camera. Then here in the editor, we can drag the virtual camera reference, okay? So now here, like I said, you might think to just go inside this object. So let's go inside this one and search for some kind of field of view, but nope, there's no such thing. Search for FOV, nope, does not exist. Looking at the inspector here, we need to figure out how to modify this field. And thankfully, Cinemachine has all of the source code available. So you can just right click on the component and click on edit script. And when you do, you should be able to see the entire source code for Cinemachine. And just in case that doesn't work automatically, you can just find it manually. So you can go into your project window and over here expand the packages. Now if this one doesn't work, then on the project window on the top right corner, there's this little icon with an eye. If this one is toggled, then the packages don't show up. But if you untoggle it, then all of them show up. And here you can find Cinemachine. Then inside you can find runtime. And then under behaviors over here, you can find the Cinemachine virtual camera. So just go ahead and open this. Here, like I said, contains all of the source code. However, over here, if you search for field of view, nope, nothing shows up. Search for FOV, nope, nothing shows up. So to get another hint, we can again look in the inspector. And over here, we see that the FOV exists inside something called lens. So then over here on the script, if we search for lens, we do find exactly this. An object of type lens settings called m_lens. Then we just need to go inside this lens settings. So on the project window, we can search for lens settings. Let's make sure to search in all, and here we find the lens settings. So inside the Cinemachine runtime core lens settings, and inside this script, now if we scroll down, yep, here we do see the field of view. So this method that we just did, this is how you can figure out how to find any field in order to modify it through code. There's an even more advanced version of this method where you can load all of the package's source code directly into Visual Studio. Doing that makes it super easy to find exactly where the field is that you want to change. In my Ultimate Unity Overview course, one of the lectures is exactly on this topic, how to find any class or any field to modify any of the many tools and features that Unity has. Another example of this is the post-processing effect. So how do you modify these various fields inside these various effects through code? That's one of the things that you can do with this method or the other one that I covered in that lecture. Also, that course teaches you how to use many of the tools and features that Unity has, so check it out with a link in the description. Okay, so back to our demo here. We already know how to get the field of view, so now let's do that. Let's go into the camera system. So we've got the Cinemachine virtual camera. Inside we can access the lens, and inside the lens access the field of view. Now with this we can change it to whatever we want. So first let's just test it out. So let's set it to something like 10, and let's do it when we scroll. So if the input.mouse scroll delta, if the y is bigger than 0, so if we scroll upwards, then we should be able to see the field of view change. Let's see. So here we are, regular zoom, now I scroll in, and there you go, it does zoom in. All right, awesome. Okay, so all we need now is some logic to use some proper values. Since the zoom is instant, we also need to handle some smoothing logic. So here in the code, first we need to store a field for the target field of view. So a private float, call it target field of view. We can default it to something like 50. Then when we handle the camera zoom, when we scroll in the positive, for this one let's increase, so target field of view increase by a certain amount, let's say by maybe 5, and if we have the opposite, so if we scroll the wheel backwards, so let's reduce it by 5. Now here you don't need to use delta time because this value, the mouse scroll delta, this one is based on how often you physically scroll the wheel. It is not something that happens on every single frame, so you don't need time.delta time. Okay, so with this we have our target field of view. Now with that, let's set a clamp to keep it within valid values. So target field of view, let's do a mathf.clamp. Let's clamp between a certain minimum and maximum. So clamp this value. For the minimum and maximum, we can define them up here, perhaps as a serialized field. Let's make a float for the field of view max, and another one for the field of view min. Let's default the maximum to about 50, and the minimum, let's say 10. So then with these two down here, we just use them. So the first one is the min. So the field of view min and the field of view max. Okay, so we have the target field of view. Now just apply it. So into the Cinemachine virtual camera, access the lens, and let's modify the field of view to the target field of view. Again, right now it still doesn't have any smoothing, but let's just make sure this logic works. So here we are, and if I scroll backwards, yep, it zooms in, and if I scroll forward, yep, it zooms out. All right, great. Except it actually has the opposite behavior that I want. Obviously this is personal preference, but I find it better that if I move the wheel forward, I want to zoom in, and if I push it back, I want to zoom out. So very simple, just up here, just swap these, so that's a minus and that's a plus. Okay, so final thing that we need is, like you saw, it's way too snappy, so let's add a nice smoothing. And we can do this with a simple lerp. I actually covered this in a quick short video. It's a super simple way to add smoothing to pretty much anything. Can be a float, a vector 3, or anything you want. So in this case, target field of view is a float, so let's use mathf.lerp. This one takes a current value, so the current value won't be the current field of view. Then the b, this is going to be the final one, so let's use the target as the target field of view. And finally t, so time.delta time. And this is probably way too slow, so we float for the zoom speed, define it as something, and we just multiply. So that lerps, that applies the smoothing, and we just apply it to the final field of view. Okay, so let's test and see if it's nice and smooth. So here, if I scroll, yep, there you go, nice and smooth, going back and back. All right, great. So I can zoom in and out in any way I want. All right, so here the field of view zoom is working. Now, like I said, this is just one of the methods. The other one would be to leave the field of view exactly as it is and just move the camera closer. So let's handle that second method, but let's also keep this one. Let's rename this function to handle camera zoom. This is the field of view method. Now let's make another one, so private void, handle camera zoom. And for this one, let's call it the move forward method. Okay, so now let's go up into our update, and over here, instead of calling that one, let's try out this second method. So here we're going to leave the field of view alone, we're not going to touch that one. Instead, what we're going to modify is the follow offset. And again, we're going to need to use that method, because if we try accessing this again and we access the follow, nope, we just see the follow target, we don't see the follow offset. So again, we need to look into the package source code to figure out what to change. And if we look here into the Cinemachine virtual camera component, on this script, if we look around, we can see that the way Cinemachine works is apparently by some kind of Cinemachine component base. So this system is set up in a way to allow for multiple components. We can see we have a function to get all of the Cinemachine components, and we got another one to get a specific Cinemachine component. And then if we look in the project window under the packages, under Cinemachine, under runtime, and then components, if we look here, we can see various interesting class names. And if we open one of them, we can actually see that they extend Cinemachine component base. So these are all of the various components that can be attached to a Cinemachine virtual camera. And if you compare these names with the ones on the virtual camera, so over here, for example, on the body, if you scroll, you can see we've got do nothing, which means no component. Then we've got third person follow, framing transposer, regular transposer, and so on. And if you look in the scripts, yep, the same thing. Third person follow, a composer, framing, transposer, and so on. So we can see that the body field here is essentially an instance of one of these components. So in this case, we're using the transposer type. So let's open up the Cinemachine transposer script. And over on this one, if now we search for follow offset, here it is, we do find this poly field and follow offset. And you can see it even defaults to vector3.back times 10, meaning it's going to be pulled back minus 10 in the Z. So that's exactly what we saw happen. So we know this is the one that we want to use. So this is what we need to modify. Let's go back into our regular script. And up here, let's first get the CineMachine virtual camera. Then we need to get a CineMachine component of that type. So let's use that function to get a CineMachine component. Then for the type, let's use the CineMachine transposer. And then from this one, now we can modify the M follow offset. Here it is, this one. Again, let's do a quick test. So let's set this to some random value. So maybe this 10 minus 10. And once again, let's do this on a scroll. Okay, so let's just test and see if the follow offset changes. So here we are, and if I scroll, and yep, there you go, it does indeed change. All right, great. So this is working, we just need to add some extra logic. So we're going to need to change it based on the scroll wheel, and then at the end we actually apply the changes. And we're going to want it to be smooth as well, so let's go up here and do the same thing that we did. So private, this is a vector 3 for the follow offset. Okay, then with this one down here, let's do the same thing. So on one of these we're going to move it forward, on the other one move it back. Now the question is, how do we move it forward? For this one we want it to zoom straight in. So we're going to need to calculate a vector 3 for the zoom there. And now the way that we calculate this, one of the simple ways that we can do is we can just say the current offset. So let's set this to the follow offset. Now we just want the direction, so we normalize this. So with this we have the zoom direction, which will go either forward or backwards. So then we can just increase, so the follow offset, let's increase it by zoom there. And on the other one, let's decrease it. So minus equals, this is on under 0. Then we need to do a quick test for the minimum and maximum. So for that, let's go up here, let's define another private float. For the follow offset min, another one for the follow offset max. Then we can default this to some values, maybe 5F and maybe 50F, okay. Now we can compare those by checking the follow offset, check the magnitude. So we just do if the magnitude is under the follow offset min. If so, then we want to set it to some minimum. So let's set the follow offset equals the zoom direction, which again is a normalized value, multiplied by the follow offset min. Okay, so this gives us a minimum, and then the opposite for the maximum. So if it goes past the follow offset max, then we set this one. So we have this, now we just need to make sure that we start off follow offset with something. So we can actually start off to the one that it has by default. So up here, let's make a private void. Let's make an awake. Then awake, just set the follow offset and grab the current one. Okay, so then down here, we just need to apply this follow offset. Now the issue, of course, that this is instant. We need to apply some smoothing. So let's do the same thing that we did, except this time we're working with a vector 3. So let's use vector3.lerp, and all logic is exactly the same. So let's grab the current follow offset. Then the target follow offset, which is our follow offset, and finally time.delta time. And of course we need to multiply it, so a float for the zoom speed. So we have our lerp, and then we just assign it. So like this. Okay, so let's test. So here we are, and if I move the scroll wheel, yep, there you go, and I zoom in, and if I go to the maximum, yep, can't go further, and I zoom out, and yep, zoom out. All right, great. So it's zooming a bit way too little, but the logic does work, except it's also reverse, so let's fix that. So up here, just swap these out, so this one is a minus, and this one is a plus. Then for the amount, float for the zoom amount, let's put it at maybe 3F, and then the zoom direction, we just multiply by this zoom amount. Okay, let's test. So here we are, and if I zoom in, yep, there you go, zoom in and zoom out. All right, awesome. So everything is looking really nice. So I can move the camera, I can rotate around, and here we've got the second zoom method. Okay, so with that done, let's actually quickly check out the third zoom method. Now, instead of zooming directly onto the position, so this is a direct zoom, instead of doing that, let's just lower the camera closer to the ground. So let's make another zoom method. So let's make another function. So handle the camera zoom. Let's call this the lower Y. We're going to lower the follow offset on the Y. And the logic here is actually going to be pretty similar to this one. So let's copy this. Except for this one, instead of moving according to the zoom direction, Instead of that, what we're going to want to move is the fall offset, but only on the Y. So only on the Y, that's the only one we want to modify. So this one, just lower it or increase it by the zoom amount. Then instead of checking for the magnitude, we can just check for the fall offset Y. So the Y equals math.clamp. Let's clamp the Y between a certain minimum and maximum. So let's define those up here. So let's define the min Y. Let's put it at maybe 10, and then the max Y, let's put it at maybe 50. Okay, so we've got these two. And now down here, based on the min Y and the max Y. Okay, so we clamp that value, and then we do the exact same thing. So we still only use the fall offset, and we do that. All right, so now let's use this method instead of the other one. So over here on our update, let's use this method instead of this one. Okay, that's it, super simple, let's test. Okay, so here we are, and if I try zooming in, yep, there you go, now it does this. So instead of pushing forward, it pretty much just gets the camera closer to the ground. So personally, I really like this method since it lets you look at objects from a different angle. So the other one, you always had this view and just getting in closer or further away, whereas with this one, we can zoom in and get a different view of all of our map. So personally, I really like this method since it gives you a different view, but either way, here you have 3 zoom methods, so choose whichever one you prefer. And with that, here is our complete camera system. We can move with the keys in the keyboard. Alternatively, we can also move the camera by moving to the edges, so we've got edge scrolling enabled. Yet another method is by clicking and dragging the mouse, so we can place the camera anywhere we want. And again, especially for this method, you can easily change this to make it work with the new input system. So making this work with touch input would be super simple. And then we can also rotate the camera so I can look at anything from any angle. And finally, I can zoom in using any of 3 unique methods. And over here is the 2D version with all of these same features. The logic is mostly the same. The virtual camera is set up in 2D, as is the camera. The follow target is the same. And for the zoom, there's only one method, just changing the camera's orthographic size. So that's it, and here it is, this same system working great in 2D. Alright, so here is a fully featured, fully working camera system. This is perfect for any game where you want to give the player control over the camera. There's a link in the description to download the project file, so go ahead and use this in your next project. There's also a link there for this really awesome asset pack if you want to get it. And if you found this video helpful, check out my complete courses. Alright, hope that's useful. Check out these videos to learn some more. Thanks to these awesome Patreon supporters for making these videos possible. Thank you for watching, and I'll see you next time.